Assalamualaikum and good evening to our lecturer Mr. Khairul Anwar bin Ibrahim. Welcome to our presentation about transmission line. First of all, I will introduce myself. My name is Muhammad Hazri Irfan bin Muazman, and my group of members is Ahmad Syami bin Azhar, Muhammad Farhan bin Adrus, Muhammad Syarul Izzat bin Muhammad Saad. Okay, let's start to our presentation. Introduction of transmission line. A transmission line is used for the transmission of electrical power from generating substation to the various distribution unit. It transmits the wave of voltage and current from one end to another. The transmission line is made up of a conductor having a uniform cross-section along the line. For safety purpose, the distance between the line and the ground is much more. The electrical tower is used for supporting the conductor of the transmission line. Tower are made up of steel for providing high strength to the conductor. For transmitting high voltage over long distance, high voltage direct current is used in the transmission line. Okay, we go to how transmission line works. Electricity is delivered to home, school, hospital, business, and industry through an integrated system of generating plants, power line, and substation. Transmission line, which consist of heavy cables strung between tall towers, carry power from where it is generated to area where it is needed. The transmission network allow the movement of large amount of power over long distance. Okay, let's go to how power is delivered to your home. Electricity is generated by utilities and other energy producers at various types of power plants, wind and solar farms. Then, electricity is tapped up or transformed to higher voltage a substation before it enters the network of high voltage transmission line. Electricity from the transmission network is reduced to lower voltage at substation, and electric distribution companies then bring the power to homes and business. Okay, for the last part is interconnection ensure reliability. Because electricity cannot be stored, it must be generated, transmitted, and distributed at the moment it is needed. The high voltage transmission grid is the vital link between power plant that generate electricity and the people who need it. In the early day of electrification, power plant were small and generated electricity for immediate areas. As demand for electricity increased, utility built larger, more efficient power plants and developed transmission system to carry the energy over longer distance to larger numbers of customers over wider areas. To increase efficiency and reliability, regional transmission systems were connected to allow power to flow from one region to another, which also lower cost by providing more path over which the bulk electricity supply could flow. Today, electric transmission grid reflect the regional approach to bulk electricity transportation. That's all for me. I will pass to the second presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syahmi bin Azhar. My number metric is B082010. So I will continue the other part for our article, which is power to the people. Uh, so I'm gonna talk about the strength and the weakness of the transmission line in Malaysia. We know that in Malaysia we have two type of transmission line, which is overhead transmission line and underground transmission line. So our article is more about overhead transmission line. So for the strength of the transmission line, so the transmission of high voltage necessitates a thin conductor, which means in long distance transmission line of electricity, long wire are used, which is have very high resistance. That means we have reduced the power losses, which is we need a thin conductor when we build this transmission line. So the second one is it transfer or carry large amounts of power over a long distance, which is I mentioned earlier. It is the same. So the third one is both the voltage control and the voltage loss are improved. With the transmission line, we are improving the voltage control and the voltage loss in the electricity system. So the fourth one is at high voltage level. This transmission has an excellent tendency to boost power efficiency. So the next one is the weakness of the transmission line. So for the first one, we know that if we want to build the transmission tower and all of the component in transmission line, we need a huge amount of money, a huge cost, relatively expensive upfront. You know that it is so expensive. And the second one is there is a greater requirement for protective equipment such as transformer, switchgear, overhead component, and transmission line is to prevent dangerous circumstance. Relay, contactor, and circuit breaker are also necessary, which means with all of these component, relay, contactor, it will add more in budget to build the transmission line. So the fourth one is to give connector additional space. So about space, if we want to build a transmission tower, we need a lot of space to build one transmission line because it is big and need a lot of space. And then more hissing noise is made when bulk electricity is transmitted. So when the electricity is transmits between one tower to another tower, it will make a hissing noise. A hissing noise. For the next one is problem that occur in transmission line. So transmission line, transformer, generator, and other components make up an electric power system. The majority of transmission line defect, the result in short circuit can result in significant current flow. As a result, there are more potential for fire, equipment damage, power supply imbalance. So in this part, there are so many problems that occur in transmission line. Some of the factor is such as typhoon factor, lightning factor, uh, overlying ice factor. There's so much factor, but for the overlying ice factor, there's no such kind of factor in Malaysia. So this is some of event that happened back in the past in our country, Malaysia. So in 1985, a sudden 600 megawatt load lost strip transmission line on the east coast and caused a blackout for several hours in 11 states. So in 1985, there are major blackout that happened in that time because of 600 megawatt load low strip suddenly. So in 1992, a bolt of lightning. This is what I mentioned earlier. The type of problem that can happen for transmission line, which is lightning factor. See, in 1992, it happened. A bolt of lightning during a thunderstorm struck four power line between Paka and Teluk Kalong in Terengganu. It caused a massive power failure across the peninsula at 3 p.m. So what happened in 1992 is also a major blackout that have happened in our country. So the last one is in 1996, a transmission line near Paka Power Station tripped at 5:17 p.m., causing all power station in Peninsular Malaysia to collapse, resulting in massive power failure. So all these three event that happen is because of the factor I mentioned earlier, which is lightning factor, uh, typhoon factor. There's so many factor. External damage factor, component factor. All of these factor can cause the major blackout, which is we don't want that to happen. Okay, that's all for me. So my teammate will continue about how we prevent this problem to happen, how we protect all of the other component from having a lot lost stream, and other than that. Thank you.
Assalamualaikum, my name is Muhammad Farhan bin Adrus, and today I will share about how have TMB proposed to improve the system and also how TMB solve the problem. First we go to what have TMB proposed to improve the system. TMB upgrade Port Klang power plant to provide power security. The construction of 275 kV transmission line from Paker, Terengganu to Tanah Merah, Kelantan in 1986 as an alternative route to dispatch power to the grid from major power plant in Paker and Kenyek, Terengganu. Second, TMB to erect an alternative transmission line between Terengganu and south of the peninsula. TMB to improve its protection system in power transmission system and to allocate 30% of spare capacity at any one time in power generating system. Third, TMB recommended that dependence on power generated from this station be reduced to a lower risk of major of major system failure. TMB is to spend between 50 million to 100 million ringgit per year in the next 5 years just to improve reliability and security of national electricity distribution. And next, we go into how TMB solve the problem. The 500 kV transmission network was to become backbone to the national grid. It was planned as a 784 km circuit stretching from northern tip at Gurun to Pasir Gudang in southern, via Kapak and Bukit Tarik in the central region. The smart grid primarily objective is to improve operational efficiency via automation. It also has the potential to be used as green energy transfer and transaction, and also facilitate power trading among ASEAN members, among many other applications. Smart grid technology will enable to grid to self-healing, flexible and also intelligent. In the long run, it also flexible, affordable and clean energy supply. The smart grid builds on the existing grid infrastructure, strengthening it with intelligent technologies. With the smart grid, manual tasks can be automated, and consumer can be empowered through direct communications. It has intelligence to perform a variety tasks according to application installed. Thank you.
Assalamualaikum. My name is Muhammad Syahrul Izzat bin Muhammad Saad. My matric number is B0820103661. Today I want to talk about what are TMB ongoing maintenance for transmission line system. TMB undertakes continuous maintenance work of its high voltage transmission network. There are three types of maintenance. The first one is preventive maintenance, is scheduled, whereas corrective maintenance occurs after failure or an unacceptable mishap has occurred. Its aim is to restore the function of the grid. The third maintenance is a live maintenance, is performed on transmission line and related equipment without turning off power to customer. This kind of maintenance is relatively new and requires special equipment and training. The primary maintenance issue are adverse weather, defective equipment, and encroachment. Adverse weather can be overcome with flood mitigation measures, pre-monsoon inspection, and lightning protection improvement works. For defective equipment, there is a monitoring and predictive replacement and rehabilitation program. To deal with encroachment, TMB turns to surveillance technologies such as the smart camera, unmanned aerial vehicle, and satellite technology. Transmission line are built with a certain capacity using a conductor type and technology available at that point in time. The challenge is to meet new power demand and transmission loads. When new power plants are added to meet growing demand, some transmission lines find themselves overburdened. They are carrying more than they should. When this occurs, its protection system will kick in, causing an interruption of power transfer from source to demand point. This is a signal to upgrade the transmission line to a higher line capacity or line voltage. Annual transmission development plan that reviews the adequacy of the transmission system over a rolling 10-year period. The review is a requirement under its licensing conditions as grid owner or operator, as well as the Energy Commission's grid code for Peninsular Malaysia. So the summary, electricity transmission in Peninsular Malaysia is starting a new chapter, now controlled by Public Utility Tenaga Nasional Berhad (TNB) as sole owner and operator of the national grid. The future holds the promise when the third-party access arrangement is implemented as part of a market liberalization in the next few years. With, with the smart grid, Malaysia will join the league of developed nation where consumer play a significant role in determining the direction of their country's power industry. Live maintenance is performed on transmission line and related equipment without turning off power to customer. The primary maintenance issue are adverse weather, defective equipment, and encroachment. For this, TMB has an annual transmission development plan that reviews the adequacy of the transmission system over a rolling 10-year period. So that's all from me. Thank you.